Okay, we've got some cards which are numbered consequently from 101 to 200 inclusive. This is important, okay, that it's inclusive. And these cards are in a box. So what is the probability that a card picked randomly from the box will be divisible by both 2 and 3 and will have 5 or 6 in its 10th digit, okay? Now, the problem asks us for a probability, and we know from theory that whenever we ask for a probability, we immediately need to write down this formula. Probability equals to desired outcome over possible outcome, okay? Let's try finding out the possible outcome first, because usually finding the PO is easier than DO, so let's do the easy thing now. Okay, possible outcome. We have numbers from 101 to 200 inclusive, okay? Now, let's count how many numbers we will have. It will be 200 minus 100. This will be the range, if you remember from theory, and we need to make it plus 1 to find the total number of integers from 101 to 200 inclusive, okay? So it will be 100. So, we found our DO, it's 100. Congratulations. Now let's go to PO. Now let's go to the DO. Well, so our number has to be divisible by both 2 and 3. And let's think about possible numbers which are divisible by both 2 and 3. Let's say 12. Can it be divisible by both 2 and 3? Yes, it can be. Now let's think about, because 12 is quite a big number, right? Let's think about possible smaller number, okay, so that we can work with it easier. The smallest number which is divisible by 2 and 3 is its LCM, least common multiple, okay? And the LCM of 2 and 3 will be the product of 2 and 3 because they are both prime numbers. So the formula for such a number will be 6k, okay? Again, you may want to revise the theory for this. So 6k, where k is a positive integer, can be divisible by both 2 and 3. You can give different values to k and see that it's divisible by 2 and 3. For example, 6k can be 6 if k is 1, it can be 12, it can be 18, it can be 600 and 6000, etc. Okay? Now, this number has to conform the formula of 6k first of all. Now, what it says is this number has to have 5 or 6 in its 10th digit, okay? So let's look at our numbers again. We have 101 and 200, so their 10th digit will be the 0 and the 0, okay? So we want to create 5s there or 6s there. So to do that, I would say the following. We can have 5s only in the range of 150 to 159, right? Only in this range. And we can have 6s in the 10th digit only in the range of 160 to 169, right? Okay. Now, so our 6k, which is the formula of our number, has to be between 150 and 59 or between 160 and 69. Okay, let's put it there. 150 is less or equal to 6k and less or equal to 159, okay? Now let's divide both sides by 6, then we will have 150 over 6 will be 25, right? This is k, and it's smaller or equal to, so 156 will be the next one, so it will be a bit more than 26, but not 27, okay? So I will put 26 point dots, okay? So this is our range of k in this case, and because we remember from theory that k can only be an integer, a whole number, then k can have only two values here, 25 and 26, right? Now let's go to the next range. Let's put our 6k in here, Okay, so we will have 160 is smaller than equal to 6k and smaller than equal to 169. You can divide things now, but I would tell you that our k is in the range of wait a second. So it's 26, a bit more than 26. You can use your school multiplication methods to calculate that. And smaller or equal to 28 point something. Okay, so this leads us to a conclusion that k in this range can be either 27 or 28, right? And these are, by the way, our DOs. Okay, this is what we desire. We want two numbers in this range, two numbers in this range. So in total, we want any of these four numbers. 2 plus 2 is 4. Okay, and this is our DO. So let's go back to our probability. We know our possible outcome and we know our desired outcome. So let's divide DO by PO. So 4 over 100 is 1 over 25. Okay, I know this is a long calculation problem, but this is a difficult problem. Okay, so even if you spend more than 2 minutes, and I bet you will spend more than 2 minutes during the test on this kind of problem, hopefully you will spend much less than 2 minutes, maybe 1 minute or even less on an easy problem. Okay, so it's okay to spend, let's say, 4 or 5 minutes on this problem during the test. Okay, so the correct answer is therefore, excuse me, why do I have here 125? It's just 25. Okay, sorry. So 1 over 25. Now, so the correct answer is A.